Hello guys, myself Arjun Kumar Verma, and this is video number 17. In this video, we will study feature engineering, creating new features from existing data. This is the important part of this session. We will discuss one by one what is about this, and we will also see the practical part of this video. Be stable with me. Let's begin this session without wasting our time. First of all, we have to understand what is feature engineering. Feature engineering is the process of transforming raw data into a set of relevant input variables called features. This is the simple definition of feature, that is the process of transforming raw data into a set of relevant input variables. This is called features, and features improve the performance of machine learning models. Next point is that about feature engineering, it involves selecting, manipulating, creating, and transforming existing features using domain knowledge and data mining technique to make them more suitable for model learning and prediction. Next point is that about features engineering. Common steps including scaling data, encoding categorical variables, aggregating data, and creating new features by combining or extracting information from raw data. This three point, I think this is the very important point which describes the feature engineering. This is the very simple in language you can easily understand. This is the feature engineering. We will move to next slide, that is purpose of feature engineering. When we study anything, we have to know what is the purpose in such a way that what we going to study, what we have to their application. So we will have to read purpose of feature engineering, and you can search many point on internet, Google, Chat GPT. But I written here most important, which describe the purpose of feature engineering. So let's discuss one by one. Feature engineering creates features that make it easy for algorithm to learn and detect patterns, resulting in more accurate prediction. By the use of feature engineering, you can increase your accuracy in prediction. This is the first point. Next point, that is purpose of feature engineering, is that it transforms raw, incomplete, or unauthorized data into a clean, structured format that machine learning algorithms require for effective training. And next point is that feature engineering allow for incorporation of domain specific expertise to create features that capture essential relationship and behavior within the data. We can also find the what are the features that are hidden in data, and what are the relationship, what is the behavior within the data you can find, which is the raw data. Next purpose is that which I include here, that is the purpose of feature engineering. And by transforming raw data into understandable format, feature engineering helps data scientists gain deeper insight into the data and relationship between the variable. This is the very important point, I think, from engineering of artificial intelligence, machine learning, and data science. Data scientists also conclude the deep thing from the data. This is the important point. I hope you will understand this. We will move to next slide, that is benefits of feature engineering. What are the benefit of feature engineering? So we will discuss one by one point which I mentioned here, that feature engineering can slightly boost a model's accuracy, precision, and recall by providing it with more relevant and useful data signals. So this is the first point, and the next point is that by carefully selecting and transforming features, technique like dimensionality reduction help create models that generalize better to new data, avoiding the pitfalls of learning noise in the training set. So this is the important that feature engineering by using we can also technique like dimensionally create models, generalize better new data from data. So this is the important point. Next and last benefit of feature engineering that I mention here is that creating features that are understandable to humans, such as time of the day or purchase frequency, make it easy to interpret models, predictions, and understand the relationship between features and target variables. So by using feature engineering, we can make data in such a way that human can easily understand, and it is easily predictable by and understand the relationship between the data and target what we're going to do. So this is the important point. I think you will understand it. So next slide is that application of feature engineering. We have uh, also that what we will study or what we be going to study. We must have to know that is what is the application of feature engineering. So here I mention 3 points, which are the application of feature engineering. It is very simple and easily understand by you. So let's discuss one by one. That is application of feature engineering. So feature engineering is used for tasks like fraud detection by uncovering unusual patterns and for financial forecasting by creating features from time series data to predict market trends. And next point is that it helps improve demand forecasting, optimize inventory management, and personalize product recommendations to customers based on their past behaviors. And feature engineering is applied to create features from patient data to improve patient stratifications and enable more accurate diagnosis. So this is the application of feature engineering. Means feature engineering is also applicable in mm, uh, scientist, that is predict and we can find the relation of the data, and it also used for in medical services that on the basis of data we can predict what are the which disease the patient has. And so this is the application of feature engineering. So we will I think this is a very simple and applicable to you. So we will move to next slide, that is a data set overview. So data set means what we data we have used in practical part. So in this session, that is video number 17, we use a source that is loan prediction data set. I take this data from Kaggle website. Kaggle is a very famous for artificial intelligence, machine learning, and it is also for competition. So we will not moving to that detail of Kaggle. So we have to understand data source. So data source is that loan prediction data set. It contains demographics and financial details of applicants, and the target is that loan status approved or not. So this is the data set overview, which we will I will show you in practical session. Wait, we will end this theory part. After this, we will move to practical part. So first of all, we have to know why feature engineering is essential. So let's see. It's a very simple. I think you will easily understand. It's a very simple and very easy. Row columns are not always expressive. New features highlighting relationship and interactions. It improves, that is feature engineering. Predictive accuracy, model interpretability, robustness against overfitting. So feature engineering can do these things, and this is the problem which is solved by first point, that is raw columns are not always expressive. So feature engineering solve this problem. So this is a very simple. You can understand that is the reason why engineering is essential for today's time. So we will move to next slide, that is categories of feature engineering. So that is category of feature engineer. I think the which I mentioned is the most. You can also see many types of on internet, but I think it will be very uh, es- essential for you. That is, I think this three I uh, taken from many things after searching on internet or many books. So we will understand that is major categories of feature engineering. So first is feature creation, that is combining existing column, and second is feature extension, that is deriving hidden patterns, and third is feature transformation, that is scaling, encoding, log, transform, binding, etc. So this is the major category of feature engineering. I think you will understand this is a very simple and easy for you. So we will move to next slide, that is new attributes used in programming. So attribute, it's a very important that what we have to use in programming. So we will use attribute, that is total income. So total income is equal to applicant income plus co-applicant income. So this is the total income, and income to loan ratio, that is total income divided by loan amount. So this is the formula of income to loan ratio, and monthly payment formula is equal to loan amount divided by loan amount term, and we will see credit history indicator, yes or no, it will be in binary form. So this is the four attribute which we will use in programming. I think previously of this. So we will move to next slide without wasting after our time. So that is transformation in use, that is what are the transformations that is used. So normalize skewed data, that is log transform on loan amount, group applications into income brackets, that is low, medium, high, standardize numerical attribute for balance scaling. So this is the transformations in use. So it's a very simple, and it's 3 point which you can easily understand. We will move to next slide, that is feature selecting strategy. So feature selecting strategy is that eliminate columns that overlap or add a little value. Example, replace applicant income and co-applicant income with total income. Keep features that strengthen predictions and aid explanation. So this is the feature is selection strategy. And the next point is that impact on model performance. So what are the impact on model performance? So by using this model information features, that is better learning, model become less prone to noise and overfitting, high accuracy and more transparent result. So this is the more impact on model performance. So we will see how it impact in practical session. So we will move to next, that is programming. So from here we will move to our next part of this video, that is practical session. So we will see here, that is feature engineering, creating new feature from existing data. This is the practical part. So here I have taken from here, that is data loan prediction. So in previously I have explained data overview in theory session. So here we will not have to discuss. We will see and understand the practical part. So first of all, we have to import important library of Python. That is first of all pandas, numpy, cborg, and matplotlib. In previous videos, you have understand this library and what are the use of this and why it is necessary. So we will not go on that. So after importing libraries, we will move to next part, that is load data set. So here we have to load data set in data in CSV form. So we will see it. So here you can copy path, and here you can paste here, that is control plus V. So I paste it here. I think I previously done it, so no need to do. And here we first of all we have to run libraries. After this we have to run data which I have load here. So after this we have to head, that is the what are the uh, it will give top 5 row. So it is uh, head here is, that is loan ID, gender, married, dependent, education, simply. So here it gives the or 5 persons data. So you can see here. After this, we have to know what is the shape of this data, that is loan prediction data. So shape is that 614 rows and 13 column. So we will see information data set, that is 13 column, that is in column there are first loan ID, gender, married, dependents, education, self-employed, applicant income, uh, co-applicant income, loan amount term, credit history, property area, loan status. So this is the 13 column which describe information about data set. Null column here, that data types here. So we will move to next part, that is I will show you run status. So you can run by entering shift plus enter. So you can see by next part, that is target distribution. So target distribution is that loan status. So value count, we will count value here, yes or not. So you can see yes, 422, no 192. So loan status you can see by using bar graph, that is y this 422 and no 192. So here you can also check it by run. So here you can see. So this is the loan status, that is yes or not. So we will move to next part, that is we will check here missing values, that is there is any type of null values or not. So you can write, that is a df data is null, that is and its sum. So we will run its program. You can see loan ID is 0 and education 0, loan, that is this is the 0 part is the null value. So we will see it by using a graph, that is heat map. So you can see the program of this heat map, that is SNS heat map is null, charbot false. So you can this using, and you can give the title of anything that what we have, and we have given missing data heap. So you can run this program. You can see loan ID here, a loan ID, you can see there is no, so there is a null value. So in education you can also see this is the part, that is so there is null value. In applicant income and co-applicant income, you can see both have null values. And in property area and loan status, you can see there is also a null value. So you can visualize this using a heat map. So we will move to next part of this practical, that is handling missing value. Here we can handle the missing value, that is filling loan amount interest true, and credit history interest equal to true. Here we have to value, and handle the missing value. We will run this program. You can see here, and we will move to next part, that is filling categorical missing value with a mode, that is here we are using the for loop. So that is for call in gender, married, or dependent, self-employed, and after this we have defined these things. So we will run this also program, you can see. And after this we will move to next part, that is print missing value after treatment, that is null dot sum. You can so you can see there are the many null values. So we will check outliers in this. So I think you have I would like to told you that what are the outliers. So outliers are the part of data which change the mean value. So we will also it's a problem. So we will also I will also explain you how to remove outliers at last. So wait. So we will move to next. That is here you can also see the applicant income outliers are also there, and in a loan amount you can see outliers are also there. So we will move to next. That is treat outliers. So here we will cap amount at 99 percentile. So write program loan cap df loan amount dot quantile, that is 0.09, that is 99 percentile. So df amount np dot where df loan cap df amount. So here is that we will run this part. You can see it's there is no error. And after this we will move to that is apply log transform. In theory session, I have also explained the transformation. So here is the use of this. So you can see df log amount. So here np dot log 1 p df loan amount. So you can run this program. After this, we will see the feature engineering, that is total income. I have also explained the total income formula. So similarly, we will use here that uh, total income is equal to applicant income plus co-applicant income. So we will run it. That is, you can see income to loan ratio. So here in previous attribute, I will explain you. So you can see here loan ratio. So this is the important part. So loan per month formula. I also explain in theory part. So here is the application of this. So you can see simply fill n is equal to 360. So we will run also this part. So that is next part is that log transformation for skewed income. So here is the program, that is df total income log is equal to np log 1 df total income. So you can see here that is program is running without any error. So binding total income. So its program is that df income being is equal to pd code, and inside it we put df total income means 0, 2500, 4000, 6000, and 81,000. So labels is equal to low, average, high, very high. So you can also see its running status, that is no error, it's run correctly. So next, that is here we will see the bin distribution by using graph, that is bar graph. So you can see the program, that is bin value count. So income value very high 247, high 224, and average 199. Sorry, 190, and low 24. So here you can see by using graph, that is low, average, high, and very high. So you can see it's in increasing order, low to very high. You can visualize this using our bar graph, that is applicant income categories. So here is the important part, that is encoding categorical variables. Here we encode, that is gender, married, education, self-employed, property area, and income win. So we here we give a data, that is df is equal to pd dot get dummies df column categorical calls, drop first is equal to true. You can also run this. Here you can see it's running, and after encoding we print the what we have to encode here. You can see we encoding columns after encoding. So you can see after this, you can see uh, we have encoded these things, that is gender, married, self-employed. So it's here. So we will move to next, that is feature selection. So feature selection, we have selected applicant income and co-applicant income. So this is the program, you can also run it. And after this, the we see the shape, that is size. After feature engineering, the size is 640, 614 and 20. That is 614 is the row and 20 is the column. Previously you have seen that there are the 13, but after a feature engineering you can see there are 20 means it's increases. We can after and we will move to next, that is correlation heat map. So we can visualize after feature engineering, that is loan amount per month. Here you can see log one by one, previous loan amount, term credit history, loan amount log. So these are the things which you can visualize using by heat map, and that is correlation heat map. So we will move to next, that is it's a very simple that you can understand. We will move to next part, that is final data set. After this we will save to next data set, that is we will save in CSV form, that name loan prediction dot CSV. So here you can see save data, data is saved. So one thing that I told you previously, we will remove outliers, which you can see here previously, here that is its outlier, and here is also its outlier. We will remove, I will explain its program, that is by removing outlier we have to define its upper bound and lower bound. So this is the program of removing outlier. You can I give the function name remove a global outlier, that is df numeric calls remove outliers, and after while true, while outlier found false. So here is the formula. You can that is, sorry, not formula, it's a code. So here you can see what we have, what I have done. So this is the simple code. You can use this for removing outlier. I use outliers in removing outliers, that is where I have removed, that is loan amount, total income, income loan ratio, and the loan amount per month. So here we remove and data and numeric calls. So print and df after shape, that is here you can see after removal outliers, the shape, that is size of this data set is at 404 rows and 20 columns. So we will check the outliers. So here is the program of check outliers, that if there is outliers exist or not. So you can see status of check, status of outliers, that is I write here program. You can also use this. So you can see I also print here, that is there is no outlier, that is you can see here, that is zero outliers in loan amount, zero outliers in total income, zero outliers in income loan ratio, and zero outliers in a loan per month. So we will see it by using graph. Here is the program of graph, that is box plot. So you can use that. I give the size of figure 12 and 8. I call a loop, for loop. So here you can easily understand, it's a very simple. So you can see there is no outliers, and it's a mean values is accurate. So here you can say in all four, that is a loan amount, total income, loan income, loan ratio, and loan amount per month. So there is no outlier. Here you can see there is outlier in this, there is outlier, and there is also outlier. So here is the program, you can also remove. So you can visualize before and after, what is the changes. You can see there is no outliers. So this is the practical session. uh, I think you will understand it. So we will end our program. So it's from Gutsky Research Foundation. I thank you for see my video. So thank you.